Okay, so let me just check if you guys are already in front of your computer. So just give me a thumbs up. All right. Okay. Very good. All right. So let us continue now. Our example number 3. So 10 minus 1 is 1, and then minus 1 is 0. And then 1 minus 0 is 1, and then 0 minus 0 is 0. Okay, so from here, where is this right here? Okay, just put here the decimal. Okay, the same concept with the binary addition. Okay, so 1, 2, 3, 4, 1, 2, 3, 4. So again, for the sake of formality, let's say for 4-bit, 4-bit, so you can add 0 right here. But, you can leave it as it is. They are just the same. It's just that, we are grouping them by 4. So any of those two will be correct. Yes, 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 of course. Just cancel those two ones, okay, before, perform the other subtraction. Okay. Any other questions so far? Okay. So how about giving me thumbs up if you guys were able to get this one? Okay, and if you have a question or clarification, so just raise your hand. Alright. Okay, so it seems that everything is good. So let us now proceed to the octal addition. So let me just write this one down again. Notepad, notepad. Where is my notepad? Alright. Right. So anyway, let's start with decimal and then octal for now. So again, in decimal, so you don't have any problem with this one since it is the same with how we count. It's just that we're going to start with 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 26, 27, 29, 30, 31, 32, 33, 34, 35. Alright, so in here, let's range it up to 35 only. And then for the octal, again, so 0 to 7 is the same. 0, 1, 2, 3, 4, 5, 6, 7. However, we don't have 8 and 9, so we're going to skip 8 and 9 and then we'll go straight with 10, 11, 12, 13, 14, 15, 16, 17. Okay, so let me just align this one. There you go. All right, so in here in octal, 8 and 9, 18 and 19, 28 and 29, 38 and 39 will be skipped. So it's continuous. Okay, even if you're already in 150, so 158 and 159 will be skipped. So next to 17 is 20, 21, 22, 23, 24, 25, 26, 27. So again, we don't have 28 and 29, so we will skip those two. 30, 31, 32, 33, 31, 35, 36, 37. Again, we don't have 38 and 39, so we will skip those two. The next one is 40, 41, 42, and 43. Okay. So, sir, why did you list those decimal sequence and then octal sequences? To make the octal addition much more easier. Okay. Like, for example in letter B later on. But for now, let's answer letter A. So 2 plus 3 is 5. So in here, the one that we have in here is decimal. So 5 is the same with octal, it's still 5. That's why we still have 5 in here. 1 plus 5 is 6. So in decimal, it's 6. And in octal, it's still 6. But in here, in letter B, 7 plus 1 is 8 in decimal. But in octal, it's already 10. That is the reason why we have carry 1 in here and then bring down, or we have 0 in here. Okay. So 7 plus 1 is not 8, but it's already 10. Okay. And then 3 plus 2 plus 1 is 6. So in decimal, it's the same with octal. Okay. 6 and 6. However, once you reach, let's say, 18, 19, 28, 29, then that's the time that you'll have some, adjustments with your answer. Especially, when you reach already 10 and above, I mean, 8 and above, okay, with the decimal. So you're now going to have a different result, okay, something like this. So are we clear so far? And how did we get 60 when it comes to 27 plus 31 in octal? Okay, very good. How about the others? Do you guys have a clarification? Just raise your hand. All right, good. Okay, so let's just answer one example. Okay, so maybe we can answer letter E. Okay, all right. So in here we have 37.77 and then 16.54. So 7 plus 4 is 11 in decimal. Okay, let me just shrink this one. Put it right there. All right. So 7 plus 4 is 11 in decimal, but in octal, it's already 13. So just put here 1 or carry 1, bring down 3. Okay. And then 5 plus 7 plus 1 is 13. So another 13. But in octal, it's already 15. So carry 1, bring down 5. Okay. And then 1 plus 7 plus 6 is 14. So 14 in decimal, but in octal, it's already 16. So carry 1, bring down 6. And then 1 plus 3 plus 1 is 5. So they're just the same with the octal. And then decimal point will go here, and then this one is in the base of 8. Okay, so are we clear so far? This is base 8, this is base 8. All right, so any other questions? So just raise your hand if you have a question. All right, so I guess none. So that's it for the Octal Edition. So let's now proceed to hexadecimal. Then again, before we do those examples, let me just list here the uh, equivalence of decimal to hexadecimal. So this one is hexadecimal. Okay. So 0 to 9 is the same. Okay. But then again, in hexadecimal, 10 is already capital letter A, capital letter B, C, D, E, oops, F, and then after that F right here, all you need to do is again continue the numbers that you have left in here. So next to 9 is 10, 11, 12, 13, 14, until you reach 19. Okay. So again, after this sequence of numbers, so 10 to 19, of course, all you need to do is continue this letter right here. But instead of G, H, I, J, and K, so you'll copy this one. However, you will add 1 beside it. So instead of A, it will become 1A. Next one is 1B, 1C, 1D, 1E, and then 1F. Okay, so let me just align this one. So there you go. And then after, again, this F right here, all you need to do is continue this sequence. So after 19, of course, we have 20, 21, 22, 23, up to 29 again. Okay, so just keep on doing that one. And then after 29, so instead of 1A, so you need to put there 2A, 2B, 2C, 2D, 2E, and then 12, and so on and so forth. Okay. However, up to 35 is already enough, I guess, because mostly it's up to 30 only, or up to 31. So 35 is already enough. Like, for example, right here, so 7 plus 9 is 16 in decimal. However, in hexadecimal, it's 10. Okay, so that is why we have carried 1 and then bring down the 0 right here. And then E plus F plus 1. So if you guys are going to take a look on the value of E and F, so 14 plus 15 is 29, plus 1 is 30. So it's 30 in decimal, but in hexadecimal, it's 1E. So that is the reason why we have 1E in here. Okay, so were you guys able to follow? So as long as you have the list of sequence of hexadecimal and octal, you know, equal to, this decimal right here, so you're good to go when it comes to binary addition, octal addition, hexadecimal addition, and so on and so forth. Okay. So yeah, that's it for hexadecimal addition. And then we have, a lots of examples in here, but I will not answer this one anymore, since they are just quite the same with the octal and then hexadecimal. Okay, so again, I'll leave this one as your practice assignment, or practice problem. And then you can let me check your work if you want, if you're not sure with the answer. So the next one right here is multiplication of binary numbers. So in here, you don't have any problem, since how we multiply in, the normal multiplication, that's how we also do it in multiplication of binary numbers. So as you guys can see, so 0 times 1 times 1 times 1 times 0 times 1 is, of course, 0. So basically everything is 0 when you multiply it to 0. And then in here, since this one is 1, all you need to do is copy those numbers. Okay, so just move uh, one space and put it right here. And there you go. You now have this multiplied number by this one. And then the next one is, of course, again, 0. So again, everything is 0, since any number that's multiplied to 0 is 0. And then in here, if it's 1, then just simply copy everything. Okay, which is now this one. So after you've done this one, then that's the time that you can now perform binary addition. So take note that this one is in binary addition, okay, not the normal way of doing or in adding it, since we are talking about binary numbers. So 0, 1 plus 0 is 1, 1 plus 0, 0 is 1, 1 plus 1 is 10, so carry 1, bring down 0. 1 plus 1 is 10, so carry 1, bring down 0. So 1 plus 1 plus 1 is 11, carry 1, bring down 1. And then 1 plus 0 is 1, and then 1 will be 1. Okay, so did you guys get this one so far? Okay, that's a good thing. All right, so I guess this one is the easiest. However, okay, all right, so we will skip this one, so since it is just the same with this one. Okay, however, in here we have octal multiplication. So in here you need to do 4 process. Okay, you cannot multiply this one as a normal way of doing it, like 1 times 2 is 2, 1 times 4 is 4. So it's not like that. So in here, so let's say when it comes to octal and hexadecimal multiplication, you'll be needing 4 process. Okay, so what are those 4 process or 4 steps? So first is we have to convert that octal or hexadecimal into binary. Okay. Second, once you already have converted the let's say 42 and 21 into binary, then you can now perform binary multiplication, just like what we have in here. Okay, something like this. And then the third step is, of course, you can now perform binary addition. Okay, which you will get this one as a result for binary addition. And then the last one, if you guys are going to take a look on this one, it's in the form of octal. So you have to convert the binary result into octal or hexadecimal. So basically, you have to bring that one back to its original format. Okay, so let's try to answer number one using those four processes. Oops. Okay. So again, the first step is we need to convert this one into binary combination. So 42 is 0, 0, 1. So we need 32. We don't need 16, but we need 8. Since 32 plus 8 is 40. And we now only need 2. So 0, 1, 0. Okay. So this is the equivalent value of this decimal into uh, binary. Okay. So the same with 21. So all you need to do is convert this one into binary. So we don't need 64. We don't need 32. We don't need this one is 1 to 8. Okay, we don't need 1 to 8, we don't need 64, we don't need 32, but we need 16. Okay, and we don't need 8, but we need 4. We don't need 2, but we need 1. So in here, 16 plus 4 plus 1 is equal to 21. Okay, so were you guys able to follow up to this point? All right. So from here, you can now, perform a multiplication, just like what we have a while ago. But before we'll do that, well, actually, you can reduce this one by removing the zeros from the left side. Okay. So from here, you can remove those 2 zeros and then those 3 zeros. So it will give us 10 and then 1, 0, 1, 0. And then in here, we have 1 and then 0, 1, 0, 1. So in here, we can now perform multiplication. Okay, so if it's 1, just copy everything the same. 1, 0, 1, 0. If it's 0, just move one step and then everything will become 0. Okay, so 1 again, just copy everything. So 1, 0, 1, 0, 1, 0. And then next is 1, 2, 3. So next is 0 again. So all you need to do is move one step and then everything is 0. And then last one is 1. So all we need to do is copy that one, but move one step, 1, 0, 1, 0, and then 1, 0. And then from here, you can now perform addition. Okay, perform binary addition. So 0 is still 0. 1 plus 0 is 1. 0 plus 0 plus 0 is 0. 1 plus 1 is 10. So carry 1, bring down 0. So 1 plus 0 is 1. 1 plus 1 plus 1 is 11. So carry 1, bring down 1. 1 plus 0 is 1. 1 plus 1 is 10. Carry 1, bring down 0. 1 plus 0 plus 0 is 1. And then bring down that one right here. So this one is in a form of binary. So we have to convert this binary into its original format, wherein we have octal. So again, in octal, you're going to group that one by 3-bit. Okay. So I hope you guys can still remember why we need to group that one by 3-bit, not by 2-bit or not by 4-bit. So in here, This is the first one. So 0, 1, 0, first group. Second is 0, 1, 1, 0, 1, 1. And the third one is 1, 0, 1, 1, 0, 1. And then the fourth one is 1, and then another 2, 0, just to make it, 3-bit for every group. And then from here, you can now read this one as one character, okay, or in the form of octal. So this one has a value of 1, this one has a value of 5, this one is 6, and then this one is 2. Okay, so this one is 1562 base 8. Okay, 1562 base 8. So were you guys able to follow on how did we answer the example number 1? Hello, hello. How about the others? So is there anyone who has a question or a clarification? All right, so I guess none. So yeah, that's how you perform multiplication if it's not in binary. So it's a 4 process. Okay, so the same with a hexadecimal. So the only thing that will change is this part. So you in here you have to group it by 4. Okay, not by 3. Since if it's by 3, then it's 4 octal. Isa pa? All right. Okay, so let's answer. What do you guys would like? 4 or 5 or 6? What number do you like, Mr. Adan? 4, 5, 6, or 3? So anything, as long as it's not octal. So we can have a different example. Number 5. All right. Okay, let me just remove everything. So again, you have to convert this one into binary. So 45.6. Okay, so 45 is still the same. 132, so we need 32. And we don't need 16, so it's still 0. But we need 8. 32 plus 8 is 40. And we need 5. So 4 and then 1. So in here we have 32 plus 8 is 40 plus 5 is 45. And then decimal right here. And then 0, 1, 1, 0 per 6. Okay. My bad. My bad. I'm sorry. So this one should be not. I forgot. Made a mistake. Okay, the one that we did a while ago was actually for hexadecimal. Okay, I just remember. Okay, so sorry for that. The one that we did a while ago is for hexadecimal because we've grouped that one by 4-bit. Okay, because in here, if it's in octal, it should be by 3-bit only. All right. So anyway, let's answer number 1 again later on. But in here, since this one is 0 to 7, so this one is up to 3-bit only. Okay, base of 7. Okay, actually, if it's a base of 7, it's ranging from 0 to 6 only. Okay, which is this one. Well, anyway, let me just repeat this one again. So in here, if we have 4, we need 1, 0, 1. Okay, and another 3-bit is 5. So 1, 1, 0. Correct. 4 is 1. Sorry, 1, 0, 0 for 4. Okay, and then for 5 is 1, 0, 1, and then that right here. So for 6, it's 1, 1, 0. Okay, and then for 3 right here, so it's 0, 1, 1. Oops, let's move it right here. And then that right here. And then 6 is 1, 1, 0. Okay, base 7, base 7. All right. So from here, you can now perform uh, multiplication. Just remove this 0 right here, since it is the same anyway. Okay, let me just erase this one. All right. So from here, if it's a 0, then everything will become 0. 1, 2, 3, 1, 2, 3. If it's 1, then everything is the same on this operand 1. Just move one step. Okay. 1, 1, and 1, 0, 1, and then 0, 0, 1. And then in here, another 1. So let me just copy this one. 1001, 0, 1, 1, 1, 0. Then another one is 1001. This is correct. 1001. And then 0. And then 1, 1, 1. And then 1. Oops. 1, 1, 1. And then 0 right here. And then the last one is the same. Just move one step. So 1001. And then 0, 1. And then 110. 110. Then from here, you can now perform addition. So 0, 0, 1, 10. So we have 4 1, so it's 100. 0, so 0 plus 3 1 is 11. Carry 1, bring down 1. 1, 2, 3, 4, 5. So it's 5 1, it's 101. Carry 1, carry 0, bring down 1. So 0 plus 1 plus 1 is 10. Carry 1, bring down 0. 1 plus 1 plus 1 is 11. Carry 1, bring down 1. 1 plus 1 is 11. Carry 1, bring down 1. 1 plus 1 is 10. Carry 1, bring down 0. 1 plus 1 is 10. Carry 1, bring down 0. 1 plus 1 is 10. Alright? And then from here, you can now convert this 1 into its original base or format. So if it's a base of 7, so by 3 bit. So this one has a value of 4. 4. I forgot. So in here, we have the decimal on. Okay, so we'll just put the decimal later on. Okay, right here. Okay, after the 3 decimal count. And then in here, another 3 bit. So it's 5, 101. And 001 is 1. And then 010 is 2. Okay. So in here, we have 2154.4 base 7. Okay. So are we clear now regarding with multiplication? All right. Okay, so let me just repeat the number 1, but the same process. So in here we have base of 8. So it is still 3 bit. So 4 is 0, 1. My bad. It's 100. And then for 2, it's 010. Okay. And then 3 bit of 2 is 010. And then 1 is 001. In this one can be transformed into 10001. Okay. And then from here, you're gonna perform multiplication and then addition. Okay. And then convert this one again, let's say by 3, by every 3 bit for you to be able to get the octal value. Okay. All right. So yeah, that's how you perform multiplication when it comes to octal, n base, hexadecimal, and so on and so forth. So let's now move on to the sign binary numbers. All right. So in here, if you want to if you want to represent positive, you need to put 0, okay, on the second part of it. If you want to represent that number by, let's say, negative, you have to put 1. Okay, so notice this one. Let me just get this one. So positive 9 has this value. Okay, so 8 plus 1 is 9, which is now this value right here. Okay, however, if you want to represent that one in positive, so we need another 4 bit wherein the most significant bit in here will be in 0. Okay, that is why we have 0, 0, 0 right here. However, if you want to represent that, let's say that number into negative, just make that most significant bit into 1. So when we say most significant bit, it is the leftmost side. If it if it's the less significant bit, it is the rightmost side, which is this one. Okay, so the one that we're going to change is the most significant bit. So 0 for positive and then 1 for negative. So yeah, that's how we represent sign numbers when it comes to binary. Okay, so we don't have positive and negative sign when it comes to binary since we only have 0 and 1. Okay, so I hope you've got the idea of this one. So are we clear so far? Okay, so that is just the concept. Okay, so we will not actually use this one. That is just the human concept. So in computer, this is what really is happening. So we're going to apply two's complement. Okay, that is being used by computers. So take a look on this one. Negative 9 in computer, it's actually 1, 1, 1, 1, 0, 1, 1, 1. Let me just check our time. So we still have 5 minutes. Okay, so very, very different. Okay, when it comes to this concept right here, and then to this value right here when it comes to computers. Now, how did we get this one? Okay, so all we need to do is perform two's complement. Okay, so we actually have 3 steps when it comes to two's complement. So for example, you want to represent this 9 into negative 9. So the first step that you need to do, okay, I guess you can answer it right here. You need to do is, uh, you know, have the binary combination in a normal way, okay, in conventional way of doing it in binary or converting it into binary. So in here we have positive 9, okay, 8 plus 1 is 9. So that is the first step. The second step is you have to apply two's complement. So when we say two's complement or complement each bit, so 0 will become 1 and then 1 will become 0. Okay, vice versa. So 1 became 0, 0 became 1, 0 became 1, 1 became 0, and then all of those zeros became 1. Okay, so I hope we're clear with that one. We've just interchanged the values of 1 and 0. And then the third one is we have to add 1, okay, uh, the two's complement value. So 0 plus 1 is 1, and then everything now is the same. Okay, so this is how our computer converts, let's say, positive into negative 9. Okay, so that is why if we're going to take a look on this one, it is the same with this negative 9 right here. Okay, so did you guys get the idea on how to apply two's complement? Okay, very good, Miss Kyla. How about the others? So anyone who has a question? All right. Okay, so it seems that most of you were able to get it. Okay, so let's answer letter B for more reference. So negative 46. So first step, we have to represent this one into positive 46. Okay, so 0, 0, 1, 0. 16 plus 30 is 48, so we don't need that. So we need 8, 40, and 4, and then 2, and then 0. Okay, so this one now is equal to this negative 46 right here. It's just that this one is positive 46. Next step is apply 2's complement. So 0 will become 1, and then 1 will become 0. Okay, 1 0 0 0 1. And then the third step is we have to add 1, so plus 1. So 1 plus 1 is 10. So carry 1, bring down 0, and then 1 plus 0 is 1, and then everything now is the same. Okay, so this one now is the representation of negative 46. So are we clear with 2's complement? Okay, is there anyone who has a question? Alright. Sir, bakit naging positive yung binary po? Right here?
Yes, sir.
That is the first step. Okay, you have to, uh, parang, ano ba? You have to represent that value first into positive before you can make that one negative. Okay, so let's say you want to represent negative 46, so you have to show the positive binary combination, and then you have to apply those two steps, which is 2's complement and then plus 1, for you to be able to get the exact combination of negative, okay, of negative 46. All right,
Thank you, sir.
so the same with this one. So write the positive 9 first before you'll be able to get the negative 9, which is this one. Okay, so since we don't have enough time anymore, so we will just continue the rest, okay, on the part 3. So overtime na tayo. Anyway,